very good afternoon to all of you. We are gathered here today to celebrate and promote the concept of Environment Day, which is an amazing kind of an initiative that helps us understand, connect to the environment once every year. However, as we always say, every day is Environment Day. I'm very happy to welcome all of you, our listeners, our audience, our students, the distinguished speakers who have joined us on this day, and especially on this virtual seminar that the Jindal School of Environment and Sustainability is organizing on this pious day, which is a very important day for people like me, and I'm sure for everybody who understands the need to keep nature first. This is the first in the series of Environment Day seminars that we are organizing, and I'm sure that the Jindal School of Environmental Studies, Environment and Sustainability will continue to celebrate this event in subsequent years. The theme of this particular virtual seminar is the future of our planet, environment, climate change, and sustainability. Again, these are terms that are not new to anybody in the present day. We all understand the need to protect the degrading environment. We all understand that we have to and must work to prevent the already incoming climate change. And we must do all that we can to ensure that we build, and because this is the time of COVID, that we only rebuild with the principles of sustainable development, if we really are serious for leaving a planet for the future generations. So that is the background with which we are organizing this particular virtual seminar. And it comes at a very critical juncture because on one side, we have this huge problem, the global pandemic. And on the other side, nature is giving us very clear signals that the impacts of global warming and climate change are now here. They're not something that's going to happen 5 years or even 10 years down the line, they're already here. So this is the background in which we are organizing this particular event. We now move on to the second session of the day. And the theme for the second session is scientific feasibility of conservation mechanisms. So we've all shared this. The Vice Chancellor also mentioned this in the morning, that environmental studies working to fix environmental problems is an interdisciplinary issue. It's an interdisciplinary challenge. So science is not enough. It needs social sciences, it needs commerce, it needs economics, it needs law, and all these need to work together for this to happen, for us to have a pleasant planet, for us to have a stable planet to live on. So we have with us some distinguished speakers to share their insights on this topic. I'm very happy to announce their names right in the beginning. We have Dr. Vibha Dhawan, who's Director General of the Energy and Resources Institute, New Delhi. We have Professor Sirup Chaudhary, who is Professor of Environmental Studies at the Jindal School of Liberal Arts and Humanities. And there is me, Dr. Govind Singh, and my co-chair, Dr. Abhiroop Chaudhary, who are both Associate Professors of Environmental Studies at the Jindal School of Environment and Sustainability. I'd like to begin by inviting Dr. Vibha Dhawan to deliver what is the keynote address for this particular session. And before I do that, I'd like to read out a brief introduction to Dr. Vibha Dhawan. There's a lot of accomplishment. There's a lot that she has done for environmental protection. So I must apologize for the paucity of time. I had to keep it brief. But like I said, this is only just a few words of the phenomenal work that she has done in the field of environmental sciences and studies. So to begin with, Dr. Vibha Dhawan is Director General of the Energy and Resources Institute, TERI, and has also served as the Vice Chancellor of TERI School of Advanced Studies from 2005 to 2007. Dr. Dhawan is a Fellow of the National Academy of Sciences, India, and is actively involved in research as well as policy development at the national and international level. In India, she is a task force member of a number of committees of the Department of Biotechnology, the Biotechnology Industry Research Assistance Council, and the Biotech Consortium India Limited. Outside India, she is currently serving as Adjunct Professor, Consul General South Asia Partnership, Michigan State University, and has also successfully completed a number of international assignments with agencies like the Asia Pacific Consortium on Agricultural Biotechnology, the International Maize and Wheat Improvement Center, and the Borlaug Institute for South Asia. She has served on the boards of prestigious organizations in India and overseas, including Jawaharlal Nehru University, Ambedkar University, Ayurved Foundation, and the Center for Agriculture and Bioscience International. Dr. Dhawan is also known to be the force behind the establishment of the highly successful Micropropagation Technology Park at TERI. Dr. Dhawan has won several awards for her splendid work and has also authored over 6 books and over 50 publications. We are very happy that she's here with us to enlighten us on this broad topic of scientific feasibility of conservation mechanisms. I now request Dr. Vibha Dhawan to deliver the keynote address for this session.
Thank you so much for introducing me. Well, I suppose all of us, we are having one goal in life, and that is that this environment or this planet should be a livable place. The recent pandemic definitely has shown us that it's one globe. It's not that we can live in isolation. Something which perhaps originated at Wuhan, it has shaken the whole world. And also many a times we think that science is very advanced, but then we are unable to overcome this little microbe and it's causing havoc. Now, we all are talking today, or rather, I should say that way back in 1972 was the Stockholm Conference where environment was taken up as a subject of concern. And thereafter, maybe many of you are aware or following TERI. In TERI, we started a study in 1997. It was called Green India 2047. And that study basically was, what is it we have lost ever since since independence? In those 50 years, what have we lost? Of course, we always, if we look at, we talk of the positives and environment because the impact is so slow that we also take liberty of ignoring it. And then we presented that if we continue on the same path, what will be the scenario in 2047, 100 years after independence? And it was quite scary. Now to say that the development should stop, that is not possible. And many of us who want to take a softer route will say that we can't go back to the Stone Age. Development has to continue and we will have to pay some price to that. Again, that is not true because it is that development has to take place but it should be sustainable. Take any activity, whether it is agriculture, whether it is transport, whether it is building, you have 2 different ways of following, many different ways, how you go about. And the other myth is sustainability is expensive, that if you follow those paths, perhaps it's going to be far more expensive and we can't afford it. And all the time when we look at, we say, what is the payback period? Payback period only in monetary terms. We are not looking at indirect impacts. For example, and your university is located in heart of the agriculture belt. What happens when we burn parali? And the other point, and I would like to mention, is that we take things in isolation. Water problem was there, and therefore we delayed the sowing of paddy. Paddy, which traditionally was sown in early May, is now sown in June end. Now plant will require certain days to grow. So therefore it is harvested in late October to early November. And that's the time to sow wheat. So where is the time for the farmer to prepare his field for wheat? So the easiest option is burn it out. If we look at the government, they are looking at what is going to be investment in buying machines so that the agriculture residue can be collected and treated. It's all economic that we are thinking only for collection of parali. We are not looking at what is the indirect impact on the health of all those who are residing in the neighborhood, in Haryana, in Punjab, in Delhi, Rajasthan. So it's a big problem. So we took care of water, but we have forgot health issues or air pollution related issues. So that is something which needs to be taken into consideration. I'll come because this particular year we are talking of ecosystem restoration. Ecosystem is that you look into all the components of a particular habitat into consideration. Of course, I started this with planet Earth, but then let me concentrate more on forests of India because they are lungs to the. So, and it was, I should say it was funny, but at the same time, it wasn't funny, but at the same time, it reminds millions of years, we don't pay any emphasis. In this time of pandemic, when we were falling short of oxygen, we have seen that people or the patients are under a people tree, so that there is more of oxygen in that particular, under that particular tree, or in that micro niche which is formed. So trees are extremely important for us. Next one. Next slide, Veer. Okay, so forests and tree resources, apart from giving us oxygen, they give us livelihood. There are millions and over 300 million people who are dependent on them. And of the total geographical area, although we say that for a healthy country, we require 1/3 of the land, or 33%. Today, we have close to 25%. And that is quite an increase because a few years back, it was barely 18 to 19%. Next. Okay. Well, I think if I had done, I would have done a better job. But anyway, so I'll just call him in operating from home, so there's a bit of a problem. Okay. If we look at biodiversity, wealth of India, again, we talk about in country, and that's how we have rich biodiversity. And yeah. There's a compression audio. Achha. Is it better now? Because there is some problem with the audio, or can you hear me?
There was some problem in between, but now it's better.
Now it's better.
Okay. Okay. So we are talking of rich biodiversity in this country. So if we talk of in terms of, I should say that we inherited, we have 4 biodiversity hotspots of the 36 which are global. While we have 2.4% of the world's land area, we have 7.8% of the global recorded species. Species, if we look at the species diversity in the country, again, in terms of whether it is birds, whether it is large cats, elephants, tigers, 60% of the total tiger population is in India. Next one. Next slide, please. Now, while we are getting so many services from our trees, whether it's food, fiber, fuel wood, genetic resources, chemicals, fresh water, there are practically no regulations in terms of how we use these services. It is only that the species, when it becomes endangered, we look into how it should be managed. There should not be harvest that it becomes extinct. But otherwise, for many, or rather till now, it is more of that it is free for all. And that's also putting a lot of pressure on the medicinal plants, because the only cost is that of collection. There is no cost of growing. So people or the communities staying near the forest or in the forest, they simply collect this important resource, and it's only collection cost that they basically get. I spoke about the air quality, that farmers, although there are now regulations, but then they are free to burn or treat the agriculture residue the way they want. There are regulations today, especially in terms of a single-time use plastic and so on, but then people don't follow. There are so many things which remain unnoticed, and that is like maybe that even the government policies, they somehow go against conservation. In the state of Punjab, electricity is highly subsidized for agriculture purposes. With the result, the farmer grows, first of all, they grow the crops which they should not be growing because they use a lot of water. Paddy is one such example. And it is, in a way, it's virtual flow of water, because for every kg of water, every kg of rice that you produce, you spend close to 3,500 liters of water. So even if you're exporting and getting perhaps $1 a kg, is this the price for water? It's not. But then those are the things which becomes political issue and are never talked about. But we need to put regulation somewhere over there. Again, good for the farmers. We all say that poor farmer, and therefore there should be subsidy on the fertilizers. What bad it is doing to our ecosystem? First of all, we are subsidizing the inorganic fertilizer, urea, and we are not subsidizing compost that is produced by the farmer by degrading agriculture residue. So you are disintensifying a technology which is far more friendly for the environment. The other is that because of the subsidy, there is excessive use of fertilizer. We spread farmers, they simply broadcast urea. So part of it gets converted into ammonia and get into the atmosphere. And part of it goes into water underneath in our aquifers. And then people are forced to drink that water, which is not good for them. On top of it, when we talk of water pollution, then it is also the pesticides and various plant disease control measures that we spray chemicals. So they also put a lot of pressure, or the negative impact on the health of people. So it is essential to have regulating services, which should also be enforced. It should just not be on the paper alone. Next one. Now, if we look at biodiversity as a whole, it is both in a way cultural services. It gives you enjoy seeing lots of plants and animals around. We go to various game parks. And more than that, it is very essential to have the supporting services that it provides. What is happening to our mountains today? When we read so much about what is happening in Uttarakhand and that region, and if you visit that area, you find it's so denuded. There are no forest cover left. And with the result, the roots of the plants, they bind the soil, they bind the rocks. So if those roots no more exist, with the slightest of rain, you have all these landslides. So that is also putting havoc, and we are realizing what is happening today because of the lack of the forest cover. Next one. Next one. Next slide. It goes without saying that if we look at ecosystems and really, and again, I'll come back to that, we can't say that go back to what was there many years back. It is more of that we also have to understand what is they are providing sustenance to over 300 million people. They provide rural fuel and fodder needs. Today, it has become a source of ecotourism and direct employment of over 350 million man days. And just these figures that they meet 40% of the energy needs in the rural India, 30% of water supply, and 50% of grazing requirements. Next one. So this is just that because of the rise in population, and while we appreciate PM's initiative of providing gas to the rural India, many of them still prefer to go for fuel wood because they find it far more expensive. They can't afford buying gas, so the dependence on fuel wood still remains. The kettle they go to the forest and for grazing, and that is still continuing, and that is putting a threat on the natural ecosystem. Forest fires is another thing which is becoming a problem, not just in India, it's all over the world. Amazon forest, California, Uttarakhand. So we are facing that, but most of these forest fires, especially in India, are human induced. And that definitely put impact on the soil cover. It causes damage to the nutrients in the topsoil, and more so in the microorganisms. And in fact, there were studies done on Jhum cultivation, whether it should continue and what are the negative impacts of Jhum because of the practice of slash and burn policy or practice that was practiced in the Northeast. Next one. The invasive species had also put a major problem. And these are just what are the major drivers. Increased urbanization, change in land use pattern. But more than anything else, I like to emphasize on the climate change issues. We are concentrating on, rather most of the studies today, they are on what will be the impact of climate change on wheat, on rice, and so on. We are neglecting perennials. These plants will live with us for many years because they are already, in a way, adults, they are growing. But with the change in climate, what are the kind of species which we are going to lose over a period of time because of the changing climate? So it is for horticultural species, for forestry species, climate change is going to have a sudden impact when we won't be able to regenerate and lose. We also discussed about habitat degradation. And we can still see what is happening to our animals, the big ones, as well as plants, but we are neglecting the microflora and microorganisms, which again are a key to ecology because we need to maintain them. And that ecological disturbance is further impacting growth of new species and habitats. Next one. Now I'll come to that. Let's look into that. All that major initiatives have been taken by the government. Joint Forest Management Resolution. It started in 1990. Again, something very interesting because see, you cannot police such large areas. You also have to provide livelihood options to those who are residing over there. And I'll share with you what is done in JFM is that the custodians of forest or those who are residing in those areas or outside those areas, they have been given certain rights and they have been given certain skill set. Because otherwise, if you tell them don't harvest, what do we do? So to them, it is that, okay, you can harvest this much and treat it like that. like if it is bamboo, you make bamboo baskets and sell them so that their livelihoods are not getting impacted, that you are stopping them to grow trees. National Forest Policy came in 1988, National Agriculture Policy, Forestry Action Plan, Environmental Policy. So there are large number of policy initiatives that have been taken in over years. And these, really speaking, they are helping conservation action to be taken. Next one. The regulatory mechanisms, again, they came simultaneously: Indian Forest Act, Wildlife Act, Water Prevention and Control of Pollution Act. So basically, what I like to talk about, that these are standard, but there is one National Biodiversity Act, or National Biodiversity Act of 202. Now, that is something which I suppose perhaps has to be relooked. It is more on shearing of germplasm. And it's becoming a major problem, especially for agriculture crops. The Green Revolution, on the basis of which India could increase its productivity many folds, was basically based on free exchange of germplasm. Now, what has happened in the recent past is that agriculture, which to a country like India is a state subject, so in case of agriculture, private players have come into play, and especially the multinational companies. Also, with the scientific advancement, we could now figure out which particular gene is responsible for which trait. Like we all are looking forward to trait for heat stress tolerance, drought tolerance, maybe tolerance to repeated floods, and so on. So the companies have patented these particular genes, and that was based on the germplasm which had gone from different countries. And as I mentioned before, that India has lots of hotspots, 4 of the 36 hotspots, and therefore we have germplasm or lots of variability in our plants. But then those genes have been patented by the multinationals, and to use that particular gene, of course, I'm not saying conventional breeding, but otherwise, if you want to get it, then you have to pay royalties on it. So when that came into existence, India as a country, we became very conscious, and we said no germplasm should go from India. And that is putting a major problem to all of us, because then it is both ways. So we are also not getting technology, we are not getting germplasm. And even for research purposes, it is putting hindrance. And that's why I say that we have to relook at it. This is more of, I discussed about where the policy gaps are there and what needs to be done. Similarly, when we look at the conserving this germplasm, it is on ex situ, in situ tissue culture in nitrogen, low temperature, and so on. So all that is being done, but it is not for all the species. And really speaking, we have to take care of all the species in the ecosystem and develop. And therefore, rather than concentrating on species, we should look at the habitat as a whole, so that they grow on their own, they evolve on their own. So that's what I would like to say. Thank you very much. So if there are any questions, I'll be happy to take those.
Thank you, Dr. Dhawan. That was very enlightening. I request you to stay till the end of this session, so we'll take up questions then. But to briefly respond, like I said, I mean, a lot of information there, a lot of impactful knowledge there that I'm sure has benefited the viewers and the listeners. You mentioned right in the beginning about stubble burning, which is really a big concern for definitely our university, but otherwise as a nation, it's something that concerns us. You also link that with the subsidized electricity that some states provide and how that also causes problems in terms of water management. So it's not just air, but also water, which is a concern when this happens. You talked about subsidy even for fertilizers, which is a big concern again, not just causes simple harm to human health, but also leads to sometimes cancer, which is a very, very concerning disease. There again, like I said, again, what kind of scientific interventions can we have there? How do we reduce the consumption of fertilizers to ensure that we have maybe organic farming? Organic farming has not catching on. It's not catching on because of several reasons. Some of them could be scientific, some of them are also policy related. So what can we do to kind of address those issues is something that definitely comes to mind right in the beginning. You also mentioned about ecosystem services, which is again something that that all of us should learn about, because irrespective of science or otherwise, because we must understand that all that we get, all that we eat, all that we consume comes directly from nature. So before we throw something in nature, before we disturb nature, that thought should definitely come in all of us. So that's, I think, a very well point put there. You also mentioned about the people tree and the need for people to rush to the people tree because of the belief that it gives oxygen, more oxygen, or even at night it gives oxygen. I'll come to that briefly in my small discussion. And of course, you highlighted certain other issues with respect to intellectual property rights on bioresources, which again is something that is a lot needs to be worked on that area as well. But I think in essence, you've highlighted and mentioned that science understands the problems. Science has an idea, a good idea of all the problems we are facing, the challenges. Science also has solutions, as we have seen. But there is a need for to build bridges between sciences and economics and social sciences for these solutions to actually reach on the ground. But something very interesting that you also highlighted along with this, with respect to the joint forest management that you mentioned, is that it cannot be that the bridge is cannot be a one-way mechanism. That social scientists, economists come to scientists, take the solutions and run away with it. So that is not going to work out, because these solutions very often need to be improvised. So there's going to be a need for a continuous team formation and not a one-off team formation saying, okay, here is a solution, take it and run, because that's not going to work. So that in essence is something that I learned from the presentation, and I'm sure many others who've been watching have been able to gather this, that how there is a huge need for interdisciplinary studies that are sustained interdisciplinary studies. So it's not a one-off study, but it needs to be prolonged. It needs to work with nature, with all the different disciplines together. And that is the only way forward if we are serious about addressing the challenges that we are facing in terms of the environmental and climate crisis. So thank you very much for that valuable presentation. The learnings were immense, and I'm sure all listeners or students have all benefited from that. So next, I'd like to now request Professor Abhiroop Chaudhary to take this Zoom virtual seminar forward. And before I do that, I'd like to briefly introduce him as well. Dr. Abhiroop Chaudhary is Associate Professor and Assistant Dean of Student Affairs at Jindal School of Environment and Sustainability. He completed his PhD from IIT IISM Dhanbad, and his thesis focused on the impact of environmental stresses on Sundarban's mangrove ecosystem. His postdoctoral research pertains to traditional knowledge at Run of Kutch, and prior to his association with JCS, Dr. Chaudhary worked as Assistant Professor of Environmental Science in Manipal University, Jaipur. He is actively involved in climate change mitigation and mangrove restoration projects in the Indian Sundarbans. Within the last 5 years, he has published more than 20 articles on environmental issues in peer-reviewed journals. He has also researched extensively on empirical cancer risk models and ecological impacts of trace metal pollutants at Sukinda Chromite Mine, Jharia Coal Mine, and the Subarnarekha River Basin. Over to Professor Abhiroop Chaudhary.
Thank you, Govind, for the introduction. I will take this opportunity to welcome our distinguished speaker, Dr. Sirup Chaudhary. Sriroop is a geologist by training who integrates environmental chemistry with geospatial analysis for nature vulnerability assessment and effective decision making. He earned his MS and PhD from West Virginia University, USA on soil chemistry and postdoc at the Texas A&M University on water resource management. He is currently a professor of environmental studies at the Jindal School of Liberal Arts and Humanities and assistant dean of research. He is the co-founder of the Center of Environment, Sustainability and Human Development at JGU. Today, he will be talking on air quality assessment during COVID-19 lockdown in India and its challenges. Welcome, Professor Sriroop.
That sounds good. Thank you so much, Professor Chaudhary. Thank you, especially to Professor Singh and Professor Dhawan. I was just trying to make a point in there is that there are several wonderful thought-provoking points that Professor Dhawan made in her talk. One of the things that I grabbed is that I've been thinking about this for a while is that in India, the national policymakers, the way the policies are made is that most of the policies, at least in the field of environmental and sustainability studies, is that they are made in a standalone way. They should be coming together. The water policy, the soil policy, the biodiversity policy, the forest policy, the air pollution policy, they should be coming together. They should be mutually reinforcing, not mutually exclusive. So I guess the way things are shaping up, it will be our next generation of bright young minds, the students who will be becoming researchers, policymakers. It will be up to them to figure out, to enforce, to impress this fact on the policymakers that we got to start thinking in a collective way, in a cumulative way. It's not just solving for water or air or for soil or something. Everything works together. Environment is a machine. You got to take care of the smaller cogs, smaller parts in there, or environment doesn't work. You cannot think of climate change alone. There's so many things of climate science, climate studies, economics, policy, food processing, water security, everything. So I guess it will be coming up on our bright young minds, the students, the young scholars, to impress this upon the policymakers. Okay, so far so good. So I want to thank you all for joining us for this meet here today. We are going through very difficult, try times. I hope everybody of us, means all of us, are staying safe and well. I want to thank JSCS for putting together such a nice effort, such a timely effort, I would say, to bring together all the distinguished speakers, distinguished scholars in the different fields of environment studies from all over the world. So thank you, JSCS. Before I begin, I would want to point this out. Let me do this. Let me share the screen. I guess you guys can see the screen, right?
Yeah, it is visible.
Okay, so the work that I'm presenting in here, basically it's partly done by me and partly one of my students. Mostly by my student. You can see his little smile in there. He's smiling all the time. Mr. Arvan Kumar, he's a gifted photographer too. He runs the JGU Photography Club too. So Arvan did her undergrad thesis on environmental studies from Jindal School of Liberal Arts. So he has always been interested in environmental policy making, environmental science, environmental management. So the time when he was finishing up his undergrad thesis, it was COVID-19, means we were going through COVID-19 lockdown. So he came up with this idea that how about looking at urban air quality in the times of COVID-19. So that's what he wanted to do. So later on, after finishing his undergrad degree, he continued staying with me as a GRIP fellow, Graduate Research Immersion Program. I guess it is one of a kind program that JGU developed a few years back to nurture the young minds so that they can get into real good quality research and education or any kind of job prospect. So Arvan served as a GRIP fellow for about 6.5 months. One of the major requirements for this GRIP was that you got to come up with some publishable manuscript for international papers. So that's what JGU does to new students, so that they can get trained by distinguished faculty on campus, so that they can start thinking as a scientist, as a policymaker. So I'll show you one thing. So Arvan has already started bringing out his paper. One of his papers, the early paper, was published by Pollution Research Journal. It's work on Kolkata. So is COVID-19 only but a short time respite? Case study of urban air quality in Kolkata, mega city in India. So this is one of the series of papers that he has submitted already. This one already, it's not published entirely. This is the galley proof that I'm showing you, but this paper will be coming out soon in a well-published form, I guess, end of this month or beginning of next month. So I'm presenting in here what Arvan and myself, we've been doing for the last 1.5 years in here, okay? So as I said, that this presentation is on urban air quality in times of COVID-19 lockdown, but I'll just give you a brief idea of what's happening. Most of you guys know a lot of it, but I must tell you here that urban air quality has been a persistent problem throughout the country. And it has been with us for the past 3-4 decades or maybe more, but it has been really aggravated in recent times because of this climate change, rapid increase in number of pollution emission sources, kind of faulty regulation things, the urban sprawl, growth in urban population and things. So there have been several regulations, laws, several policies, several mitigation efforts that have been going on over the past decade and a half. But this time the government of India, the ministry, particularly Ministry of Environment, Forestry and Climate Change, they came up with a program which they call National Clean Air Program. The main idea, there were several ideas, several objectives in there. The main idea was that to streamline the efforts, the urban air quality issues, the urban air quality mitigation, restoration issues, bring everything together under one roof. That was one of the major issues. The first thing that, so this program was launched, officially initiated in 2018, and it started formally functioning beginning of 2019. The first thing that they figure out, there are several non-compliant cities, mega cities, small cities, everything. Non-compliant cities means city where the urban air quality doesn't comply with the environmental benchmarks, the national or international. So they call it non-compliant city. So in the first round, they want to focus on this non-compliant cities to figure out what's going on in there in terms of their policy making, their mitigation activities and things. So you can see the map in here. Now in here, I'm showing you non-compliance in terms of one factor, PM10, particulate matter 10. By this time, you can see all of us know what is PM10, PM2.5. These are small particles, really fine microparticles floating all over the atmosphere based on their diameter, 10 micrometer or 2.5 micrometer, we call it. Generally, PM2.5 is more dangerous for respiratory cardiac functions than PM10, but PM10 is not good either. So this one classifies the cities, the non-compliant cities in terms of their average particulate matter 10 concentration, monthly concentration. Why this topic is important right now? Now, as we know, we're going through a global pandemic. We are trying our best to get rid of the thing, but the thing is staying. First wave, second wave, people are already anticipating the third wave sometime the end of this year or something. Now, there has been a renewed interest in urban air pollution in the backdrop of COVID-19 or SARS-CoV-2 virus. The issue is that recent global research, like manuscripts that came out in past 1.5 years, something, they show that there could be a direct link between polluted air, poor air quality, and SARS-CoV-2 virus. What they're showing that both these two things, poor air quality and SARS-CoV-2, they attack the respiratory and the cardiac system. So there might be some link that if the places, the cities where there is already complaints of low air quality, poor air quality, it might predispose the people to a more violent form of SARS-CoV-2 virus. Now, this is still a theory. There is a lot of mechanistic work, process level work going on around the world. It is not an established fact, but some manuscripts have already started showing that thing. So what I'm going to do is that I'm going to show you some of our research work that we have done through that COVID-19 pollution in here. If you guys can give me 1 minute here, please just give me a minute here. Okay, my throat is parched actually. So I just need a sip of water. Just give me a minute here. So what we're going to show you here is that the kind of research that we have been carrying out for the past 1 year or so, that what happened during the COVID-19 lockdown of 2020. And also later during the unlockdown phases. Now, as we know, that the lockdown period in India ran from March 25, arguably from March 22, but we're taking it from March 25 to May 31st. Since then, it's been unlockdown. There have been several phases of unlockdown through June, July, August, September. Even during the lockdown time, we divided it. There were several periods of lockdown 1, 2, 3, 4, finer divisions in there. So we want to show you in here that what happened during the COVID-19 lockdown in 2020. We'll also be showing you that how the thing affected, means how the urban air quality was affected in the recent years lockdown. As you know, in several cities of India, we are having the second lockdown period due to the second wave of COVID-19. So that's what we're going to do. So I'm going to show you a few data sets in here. It might be confusing, but I'll try to explain it as best as I can. So stay with me here, please. So on this graph, on this set of graphs, so I have in here 6 cities: Bhiwani, Fatehabad, Ghaziabad, Muzaffarnagar, Noida, and Hisar. Now, as you know, all of the cities occur in the National Capital Region. Unfortunately, by far, National Capital Region is one of the most one of the areas of major concerns in terms of urban air quality, ambient air quality. Now, these cities also feature pretty high up in the global worst 30 air pollution list. Means every year by year, you will be seeing the names of the cities mentioned in the global worst 30 list in there. So what I'm showing you here is that distribution of particulate matter. Distribution of particulate matter 10. So that's on the y-axis. In the x-axis, as in different periods of lockdown and unlockdown and post-unlockdown, winter and spring season. Now, all these lines in here, all these jagged lines in here represent the daily concentration of particulate matter in 2019 and 2020. This dark line, this dark jagged line is 2020, the concentration, how the PM10 concentration fluctuated. And this gray line, light gray line, represents 2019. This blue line, this blue dotted line, this blue straight horizontal dotted line, this is the environmental benchmark for PM10 as designated by World Health Organization. And this red line is the environmental benchmark for PM10 as designated by the national government, the Indian national government. This black line, this black straight line in here is the separation line between lockdown and unlockdown. In here, on this side, everything is unlockdown, post-unlockdown, spring, winter, and things. And this one is unlockdown in here. So if you would notice, in all the cities, we see a slight drop in particulate matter 10 concentration from the pre-lockdown period. Pre-lockdown period we have taken from March 5 to March 25. There's been a little drop in here, but as soon as we have crossed the lockdown period, we have gotten into the unlockdown period, and as we are moving into the winter and spring seasons, we see a pronounced jump, major spikes in most of the cities. In Ghaziabad, you see, there's been huge jumps, which means the particulate matter 10 ceased to comply with the environmental benchmark, either national or global. Means all of the graphs, you'll see, this pattern is pretty common. Spring and winter is pretty common. Now, what I want to show you in here is that even during the lockdown phases in some cities, why they are being listed in the global worst 30 scenario. Even during the lockdown phases, the particulate matter 10, it doesn't really comply. Even during the lockdown, they don't comply with the global standard and sometimes with the international standard, which means that lockdown or no lockdown, means if you are enforcing, means if you are trying to check whether your ambient air quality complies with environmental health benchmark, it is a grim picture. If we move to the next slide, this is Kolkata. Now in Kolkata, this has been one of our first studies. So we have got only a couple of phases of lockdown, the whole spectrum of lockdown, and a couple of phases of unlockdown. I guess it runs till August 10. It stops at September in here. So I'm showing you in here various ambient air quality values, ambient air quality parameters, PM 2.5, particulate matter 2.5 and 10. We have nitrogen dioxide and we have carbon monoxide in here. Now these bars, this deep green bar, it represents the median value for this pre-lockdown phase, the median value of pre-lockdown phase in 2020, and the corresponding value in 2019. It goes same for each. Deep green is 2020, light green is 2019. So as you can see, if you plot up the data, say for example, PM 2.5, PM 10, nitrogen oxide, nitrogen dioxide, or carbon monoxide, if you see this, there's been a sharp drop during the lockdown. There's been a sharp drop, but it has started coming back up again during the unlockdown. So this trend line, if you follow this trend line for 2020, this deep green lines, if you follow this trend line, you'll see these trend lines are a little bit different from 2019 and 2020. For 2019 period, this light green trend line, it's steadily coming down. But in here for 2020, it first went down. Then as soon as unlockdown began, it started growing up. Now, this one in here is a little complicated thing. I'll just briefly to tell you about this. We just calculated the difference between 2019 and 2020. So subtracting 2019 concentration from 2020 concentration for each period of lockdown 1, 2, 3, 4, and unlockdown. Now, as you can see, if the difference is negative, as the difference is growing up, the difference is going up with the lockdown phase, lockdown 4, which means that 2020 was getting better in comparison to 2019 till the end of the lockdown phase. But difference between 2019 and 2020 started becoming small as soon as we got into the unlockdown phase, which means we are going back into the life as usual scenario. 2019, we took as a baseline thing, as life as usual scenario. So the lockdown partially helped, but as soon as we got into the unlockdown phase, everything was turned upside down. If you look at Delhi in here, so Delhi, this is divided in 11 districts. There are 39 monitoring stations. So what we are doing here, we are comparing between 3 years, 2019, 2020, which is the first year of a lockdown, and 2020, it's a recent year. Now, Delhi's been observing the lockdown, the second year of lockdown since April 20. So we pulled together the data from April 20 to May 22. Of course, the lockdown been extended far beyond that, but we took the data from this period, a month of data, for each of this monitoring station for different parameters. Particulate matter 10, particulate matter 2.5, nitrogen dioxide, carbon monoxide. But what I'm showing you here is just the representation of air quality index. Now, air quality index is a summary expression for all the ambient pollutant types. There are mathematical formulas to put everything together to come up with one representative number, which will represent everything, whether air quality is good or bad. So that is the air quality index. Now, if you look at this graph here, we are showing the distribution of the data between April 20 and May 22nd. So we took daily measurements of air quality index in here. So this is 2019, this is 2020 data, and this is 2021 data for the same time period. We are taking 2019 as a life as usual scenario in here. Now, these are the classifications done by CPCB, Central Pollution Control Board, which is the nodal agency of taking care of all the pollution-related activities in the country. So which shows that if air quality index is below 100, it is good or satisfactory, minimum health impact. But as you go beyond this thing, there are serious issues of health. The thing that I want to show you in here is that this is 2019, this is the median value. This line in here is the median value. This is 2021. Despite the lockdown, we figured out, despite the lockdown in 2021, it's a partial lockdown, there is no doubt. Despite the lockdown, there is no statistically significant difference between 2021 lockdown and 2019 life as usual scenario. 2020 fell way below, which means 2020 had a way better air quality scenario than 2021, which means we are back to square one again. In this graph, I'm showing you station-wise data for this April 20, May 22nd. We figured out that the percentage of days each monitoring station, the air quality index exceeded the good satisfactory limit. And we compare 2019, 2022, and 2021, which is given in bright red and golden color in here. If you look at 2021, if you look at 2021 station-wise, you'll see there are several monitoring stations which showed that for 100% of the days between April 20 and May 22nd, the lockdown, 100% of the days, the AQI reading exceeded the good satisfactory benchmark, which means there could be serious concern for respiratory or cardiac issues. 100% days. For 2020, look at 2020, this black box is in here. 2020, there were only a few readings. There were only a few readings with a high percentage value, which means for this monitoring station, say for example, Nehru Nagar, it shows for in 2020, about 82% of days between April 20 and May 2022, the AQI reading exceeded the good satisfactory benchmark. So what we're asking from here is that, does this lockdown, the social distancing, the economic shutdown, stopping of vehicular movement, does this really help in changing the ambient urban air quality? Or are there any other issues in there? So we are asking through our research is that, what do our policymakers need to make informed decisions in future? What kind of things? What are the things? What is the key ingredient that we need? What will it take to conduct process level research into air pollution COVID-19 nexus? Say, for example, what the global research is showing all over the world is, does it apply to India too? That regions which are suffering from tremendous air pollution, we are getting maximum COVID-19 cases from those areas too. Do we know our regulations are yielding desired results or not? So one of the major focus of our research is that whether the data that we are getting from the government archives, now all this data have been taken from governmental archives, the CPCB, Central Pollution Control Board archives, they give out free data. They have got an open source website, open source portal. Anyone can go in there and download the data, conduct research and things. So whether that data is whether the data has got good space-time representability, whether it's representing the spatial pattern adequately, the space adequately, or the time, whether we are getting a continuous data record across time. Now, I must tell you this thing. For Delhi, I had 39 monitoring stations. Delhi is one of the most valued, studied locations in India. I got numerous air quality monitoring stations. For Kolkata, this data comes from only 2 monitoring stations. There are 7 continuous real-time air quality monitoring stations in Kolkata, but most of them are either not functional or there are major data gaps through time, so we cannot use them. So only we found two monitoring stations which has got continuous record for 2019 and 2020 lockdown period. So that's one of the major issues that we are focusing, and we are trying to draw the attention of the policymakers to this one, whether the data is representative of space and time and whether the data is reliable or not. So that is also one of the major focus of the National Clean Air Program, knowledge and database augmentation, beside strengthening institutional governance mitigation actions. But data is one of the major issues that National Clean Air Program is focusing. It's called the age of data revolution. So I'm showing you one thing is that I'm gonna skip this thing for a minute. So what I'm showing you in here, this is Delhi as we were talking about. So in Delhi, there are 39 air quality monitoring stations, 39 of them. The first thing we figured out is that between April 20 and May 22nd, we were checking each monitoring station day by day, each of the monitoring stations. What we figured out is that is what you can see in this graph. So we are comparing between 2020 and 2019, 2020 and 2021. So this dotted line is 2021 during the lockdown period, and this black box is 2020 during the corresponding time period in 2020. Percentage of days lacking AQI data for various reasons. I'll be telling you about that in a minute. So you can see in here that there are several monitoring stations. There are several monitoring stations during the current lockdown period, current year's lockdown period, where data is missing for 100% of the days between April 20 and May 22. We don't have data for this reason or that. I'm going to explain it in a minute. Apart from that, so that's the issue of continuous record in time. So even if we want to compare same monitoring station across 5-year period for a month for each of the 5 years, first thing we're facing is that we don't have same number of days for each year. So that's a major blow to sincere decision-making or policy-making in future. The other thing that we figured is that, as I said, there are 11 districts in Delhi. There are 39 monitoring stations. So we tried to figure out that what is the density of monitoring station for each district. But even before that, we figured that the distribution of monitoring station is uneven, is partially uneven, is not equal. More than that, say for example, the Northeast monitoring station, the Northeast district of Delhi, this district doesn't have a monitoring station at all. So we have no idea what's happening in terms of AQI, air pollution, respiratory disease, or anything of that sort. Now, a main reason, there are several reasons for that. I'm trying to focus on just a few of them. The air quality monitoring stations are mostly installed by convenience of installation, not where the air quality monitoring stations are actually necessary needed, like the density or propensity of the emission sources, type of emission sources, the pollutant loading, daily pollutant loading or monthly annual pollutant loading, types of pollutants, ambient background concentration, which is a major thing. To figure out what is the natural concentration, natural ambient air concentration of particulate matter 10 or 2.5, that's a major thing to figure out whether there is a particulate matter pollution at all or not. In India, naturally, the natural background of particulate matter is pretty high compared to other nations. Now, when this monitoring stations are installed, just the convenience of installation where we can go and set up a monitoring station, not by the scientific practice. Rarely a SWOT analysis is done. Strength, weakness, opportunity, or threats. Means what will be the issues associated with the monitoring station after the monitoring stations are installed in there. So we are lacking a forward thinking vision. What might happen to this monitoring station in the next 5 years? Will we be having enough manpower, personal, finance to maintain the monitoring station? The third thing is that there is not much of community mobilization yet. Little or no consultation with the residents, urban residents of this region. Say, for example, Southwest District of Delhi, Southwest District, this is a huge swath. This is a huge region. It got only 2 monitoring stations, maybe 3, maybe they've brought up a new one. But when we were conducting the study, there were only 2 of them. There is no community mobilization yet. There is no active consultation with the people whether you need a monitoring station in here or not. There is no workshop training program and nothing of that sort. There is no means to value the urban residents' expectations, aspirations, or grievances in there. And lastly is that there is little opportunity of public-private partnership modeling. These models, these monitoring stations are still based on the state government or the central government's effort. The industry financing, the private financing, yes, yet still minimal or non-existent. So that's the issue of the space-time continuation. That's the issue of space. For the time, as I was saying, lacking data. It should be lacking, not F. Okay, lacking data. By the norms of CPCB, there are 2 ways to classify the data: no data or insufficient data. Both together we call lacking data. No data for the last 24 hours, which means monitoring and data determination involves a long chain, basically. It moves from the sensors to calibration of data, data acquisition, transmission to the central database. There could be disruption at any stage. There could be disruption at any stage of this long supply chain, and we'll be calling it that there is no data for the last 24 hours. During the lockdown, we faced this thing. During the lockdown of last year, we faced this in several occasions. We are facing it on several occasions too, that people are not going to the sensors actually. They're not able to go to the sensors actually to check whether the thing is working or not. Insufficient data for last 24 hours. Technically, the AQI, the air quality index, as I said, that it is a cumulative expression of all different pollutants in there. The AQI, the way AQI is computed, if there is information for at least 3 pollutant species, say for carbon monoxide, nitrogen dioxide, sulfur dioxide, but out of those 3 species, one of them at least should be one form of particulate matter, PM 2.5 and PM 10. There are several monitoring stations in the country, in several states, in several cities. We have monitoring stations which do not record any PM 10 or PM 2.5 data. Means either PM 10 data or PM 2.5 data. So that's the problem. Not only that, apart from PM 10 and 2.5, you have to have the data about those 3 pollutants for minimum of 16 hours of information about the concentration of each pollutant species. If these criteria are met, then you can have 3 pollutant species, and then you can go on to calculate the AQI. The last thing is that the way things operate right now is that data from the sensors, the sensors that are collecting the data, ambient air quality, the concentration of the pollutants, they're directly fed into the central government's database, the CPCB database, without much of scrutiny, whether data is good or not, whether there are outliers in the data, exceedingly high or exceedingly low value. So what I'm trying to tell you is that besides the spatio-temporal representability of the data, there are also issues of data reliability. These are all things that might affect and inform policy making later on. So for example, I get a data, I'm saying particulate matter concentration is excessively high. So I set up a very, very stringent particulate matter policy, stringent air pollution policy for a region. But later on, I figure out that the sensor during that 1 month wasn't working properly. So every number was shot way high up. So there is no way of checking quality assurance, quality control or something. But I'll end my presentation here talking about just one thing, that what we can do to get rid of that spatio-temporal thing, means lack of data. Research around the world working on low-cost sensors. These are not as good as the real-time monitors that we have, even though research shows that they are of comparable quality to the real-time monitors that the government installs. But the best thing about these low-cost sensors are cheaper, and they have become really available right now. It can increase the density of monitoring, complementary monitoring. I'm not saying that the monitoring should wholly be done based on this, but in regions where you do not have an air quality station, you can have these low-cost sensors. These low-cost sensors are wireless and mobile sensors. You can take it in your hand, put it on your bike. You can move around to monitor the thing. It can be handled by 1 or 2 persons. But the problems with this air quality sensors is that there are different sensor technologies, particulate matter versus gaseous pollutants. Say, for example, nitrogen dioxide or sulfur dioxide. Those are the gaseous pollutants. You have to have different sensor technologies for them, while for particulate matter, you have to have different things. As long as you understand that, you can connect these different sensors together in a sync. It might work, but the expenses might go up a little high. There could be drift in data. The data can go up and down. For that, there is a frequent need of calibration and recalibration. It's a little difficult thing. It should be a matter of a different lecture altogether. But calibration, recalibration to get rid of the drift in data is essential. And what this could be done, as far as I know, is Gurugram. They have already brought in low-quality sensors, low-cost sensors, not low-quality sensors, low-cost sensors. They have already installed about 22 sensors in about 20 sectors of them. The main idea, Gurugram right now, they have got 4 monitoring stations. Up till 2020, they had only 2 of them. Then in 2020, just before the lockdown in March, beginning of March, they brought in 2 new monitoring stations. So they've got a pretty robust network of things. But unfortunately, as these are new stations, we do not have the long-term aspect. Comparison across long-term is difficult. But with this low-cost sensors, if we can bring in a policy of active community engagement, bring in the urban residents into the mainstream of air quality monitoring and assessment for money, for finance and operation and maintenance of the thing. Of course, it will take workshops, extension teams and things. But by this, the urban resident can take part in this. Means all their expectations, aspirations, grievances that we don't have any monitoring stations in here, it can be made good. They can walk around, they can stand somewhere and get the data. They can transmit the data to governmental server, and that can be incorporated in the government archive with a separate post or something. So this thing's been tried all over the world now. I think it's time for us to do that too. Okay, I'm gonna stop here for now. And if there is any question, I'll try to take it.
Thank you, Professor Sriroop, for this wonderful deliberation, particularly in this COVID time, and air pollution is one of the most focal points. And I can see that there are lots of publications coming up in different academic networks. This put a very interesting preview on how the monitoring system can develop and how we can get more robust data. And I thank you. With this, I would like to invite Dr. Govind Singh for a talk. Dr. Govind Singh is Associate Professor, Assistant Dean of Academic Affairs at Jindal School of Environment and Sustainability, with over 15 years experience of being associated with environmental sector. Prior to his association with JCS, Dr. Singh worked as Assistant Professor or Environmental Studies in University of Delhi, from where he has also completed his PhD degree in 2013 and an interdisciplinary master degree in environmental studies in 2007. He has since been working to promote environmental education in higher education institutions across India and South Asia. Dr. Singh is also the co-founder of UN-endorsed Delhi Greens organization, where he has implemented environmental awareness, sustainable livelihood, and deep ecology-related projects. Now I invite Dr. Singh to deliver a talk on need for convergence of scientific knowledge and traditional knowledge.
Thank you, Abhiroop, for that wonderful introduction. I'd like to keep it brief. I can see we are running out of time. So just 5 minutes. The aim of this talk was to highlight the need that we have to enhance our scientific knowledge and enhance really fast, because change is happening really fast. And the reason why I say that is because we know that, as I mentioned in the beginning, that signs from nature are very clear. The signals from nature are very clear that climate change is now upon us. It's something that's already impacting us, and we are facing the heat, right? I mean, figuratively and both literally. Time for calling it climate change is over. It's now climate emergency, as has been abundantly made clear since morning. There are more frequent disasters. They're coming more frequently. They're coming with greater strength at us. Forest fires, as already been mentioned, is increasing in spread. The global water cycle is damaged. It's not doing well. NASA recently made a press release talking about how, giving us data in terms of how the water cycle has been impacted in a manner that there'll be droughts where there have been rains, and there'll be rains where there have been droughts. So things are in trouble. We know that for sure. And we are, as I already mentioned, we are fighting a pandemic right now. And the moment we come out of this pandemic, hopefully sooner, we have this other huge crisis upon us, which is the climate emergency that I've just talked about. So what's happened really is that we need more knowledge to fight this. Why I say that is because we have existing scientific knowledge has not been enough. It has led us to where we are. I wouldn't say go to the extent of saying that science has failed, because I've already established that science has all the solutions. It just needs to build those right bridges with the other sectors, being economics, being social sciences, for those solutions to actually make sense and be realized on the ground. So we need to make those bridges fast. There is no dispute about that. But at the same time, in the near future, what's happening is the fact that we have to not just fight or prevent climate change, but also prevent what is already happening to us. Right? So there is more climate change happening that needs to be prevented. And at the same time, the impacts of climate change need to be adopted, adapted, and fought. And that is something we need to kind of understand, that we need to mainstream all those impacts, realize all those impacts in our daily lives, and make those changes, which also needs scientific solutions. So we are in a bit of a trouble because we have climate change happening. We need to prevent it. It's already causing impacts. We need to mitigate and adapt to those impacts as well. So there's a lot of scientific knowledge that is required. And here I say that scientific knowledge is not adequate or cannot be generated too fast. And so we need an additional knowledge database to handle that, to solve this crisis. So where is that going to come from? And therefore, I mean, based on a lot of experiences that I've had in my life in the last 15, 20 years, working in the environmental sector, studying subjects like botany, studying subjects like economics, ecological economics, is from a field called traditional environmental knowledge, or simply traditional knowledge. So we need to learn from our traditions, we need to learn from our tribals, we need to learn and dwell on this knowledge and use it to augment our existing scientific database. And there's a huge need for that. And I mean, I would not go beyond that because, like I said, we are running out of short of time. But to understand or to realize, that and to accept that this is something that can actually happen, and this is something that can actually augment our existing database, we don't need to do a lot of research. We just need to look, right? And simply look, right? And in this case, I mean, I can give you a lot of examples that I found by just looking. In this, some of these were just looking over the internet, but just looking around us also. And one quick example that all of you can Google up yourself and find out is that with respect to hazards, with respect to disasters that are impending upon us, right? We know that we have tribals who already have a lot of solutions. And I'll just give one example and leave it at that. If you Google up and research, you'll find out that when in 2004, the South India part of the country faced a huge tsunami, right? There was huge destruction of livelihood, of lives and whatnot. We find that in a remote island in Andaman Nicobar, there was a government installation and there was a group of tribals living called the Jaravas. And after the assessment was made that what kind of damage has happened because of tsunami, because a lot of government buildings had been destroyed, a lot of government property had been lost. So the government was scared that this small tribal group there would have probably been wiped out, because what chance do they have to stand if robust concrete government buildings could not kind of withstand. But upon preliminary research, they found that not a single Jarava tribal was impacted because of the tsunami. So the government and the various agencies were very surprised, and they made some preliminary investigation on what happened. And they found that the Jaravas, in their folklore, they had this knowledge that when the sea recedes, because that's what happened when the tsunami came, the sea first receded and then came in full force. So their folklore told them, which was hundreds and thousands of years of knowledge, that when the sea recedes, you must run towards the high ground. You must find the highest ground close by, a hillock, and run towards that. So that was the folklore that they had. So they saw the sea receding and they all ran towards the folklore, and they knew, and this is exactly how they got saved when the tsunami got struck. Right now, how do we access this traditional knowledge? How do we reach there? That is the challenge that I throw to all the students, to all the researchers, all of us, because that is what is needed to augment our existing knowledge base. And this is going to be very critical if we have to fight the climate crisis in the near future. So there's a lot more I had, but like I said, we have paucity of time, so I'll conclude here. And I'll pass on the stage again to Dr. Abhiroop.
This is a very interesting discourse that we got from different experts who have showed light into different aspects of scientific research. And we always agree that there should be a synergy between all other subjects along with science. So just to keep the things short, I will say that there is recently, few days back, there was a cyclone that has hit in Sundarbans and different parts of eastern part of India, that's the Yash. So I will briefly show two pictures and conclude the session, showing that what kind of devastation it has done. So let me share. This is a devastation that has happened just few days back, a week back, when half of the islands of Sundarban, which has a population of about 4.6 billion, was totally underwater. And one of the examples that I will take from Professor Govind's example and also from Professor Vibha, that it is the ecosystem-based approaches that can be one of the solutions. So the places that have mangroves are one of the very unique ecosystem that can stop the cyclones and that has a power to stop the disaster from happening. It can actually play a very key role because wherever we have mangrove, it has shown very little damage and flooding. So with this in mind, I'll stop the sharing and I will conclude the session and give the session back to Professor Govind. I think we have a very interesting discussion where different people have shared and who are the experts in their field on different processes and how scientific knowledge can work alongside with all the other subjects to make the world a better livable place and obviously to protect our environment. Over to Professor Govind.
Thank you, Dr. Abhiroop. So I think we've run out of time, so we can't take questions, accommodated questions right now. I'd like to thank Professor Vibha Dhawan for the amazing learning that we had from her presentation. I'd like to thank Professor Sirup Chaudhary from the presentation that he has delivered, which has given us an interesting insight into the air pollution crisis that Delhi is facing. I'd like to thank our organizers here, the outreach team of JSCS for wonderfully conducting this event. I think it has become abundantly clear that science has all the technical solutions, but science alone is not enough. So we need economic solutions, we need social solutions to work with scientific solutions, which requires for young professionals, right? So therefore, this is news for all school students. This requires young professionals to come join courses which are making this happen, which are making technical solutions bound with economic solutions, social solutions for solving the climate crisis and the environmental crisis. So with that, I'd like to conclude. Over to Ishan.
Thank you so much, Govind. Thank you, Dr. Dhawan, Dr. Chaudhary, Dr. Chaudhary, Abhiroop, for gracing this occasion. Now, to all of our attendees who are watching us live on YouTube, if, as Govind mentioned, it is not just about science, it's about economics of it, sociology of it, legal and policy of it. I think Professor Raj mentioned in the inaugural session that it is also about governance, which is a major challenge. So during the thematics throughout the day, we're trying to cover as many of them as possible. And we've had extremely informative and enlightening session on science, and we're now following the sociological aspect, especially the sociological aspect of waste. So we'll have a 5-minute break, a session break between this session and the next one. And we'll see all of you in exactly 5 minutes from now. So thank you so much for joining in. And again, thank you so much for the panelists. Thank you.